We are solving a NEET 2019 question in moving charges and magnetism. It says a straight conductor carrying current I splits into two parts as shown, right? So you can see as the current approaching here has split into this parts and this parts, I1 and I2. Radius of the circular loop is R. The total magnetic field at the center is how much? Here you need to understand that magnetic this behaves like a combination of two arcs. You know where is the arc 1 is? This is arc 1 with all the red color I am marking. With how much angle? As this angle is given as 90, this angle will be 360 minus 90, that is 270 degrees. Is it not? This is all together for 360 degree angle. 360 is divided into 4 parts in that, out of which 90 is gone. So 360 minus 90, that is 270. Yeah. So through that a current I1 is passing, and if you look at the other part, this is the other part. Through this there is another current I2 is passing where the angle is 90 degree. So due to the upper part there is a magnetic field developed. How much is the magnetic field developed? For that first we need to know magnetic field due to a arc, current carrying conductor, due to a current carrying conductor in arc shape as mu naught by 4 pi I by r into theta, where theta is the angle of the arc that has to be taken in radians. So how much is this? Mu naught by 4 pi, current is I1 there, radius is r, theta is we can say that's angle is 370 in terms of radians, that is 3 by 4th of total angle 2 pi, is it not? Totally that is 360, this is 3 by 4th, this is 1 by 4th. So how much is that? Mu naught by 4 pi I1 by r, this is 2 times 3 pi by 2, that is B1. That B1 also has some direction. How do you find the direction? We can use this right hand thumb rule, but as the conductor is curved like this, we shall curl our 4 fingers along the direction of the arrows that I am drawing, right? So please take your right hand, curl your fingers in the direction, and notice that your thumb is going inward. So this B is inward, right? Now look at the other part, the second part of the problem. This part, due to this part, we can write B2 as mu naught by 4 pi. This current is named as I2 by r, and that theta is pi by 2. Look at the direction again. So you have to again curl your fingers in the direction of the current, 4 fingers in the direction of the current. So you curl your right hand fingers in the direction of the current, you notice that your thumb is outward. So for the upper I1 current, I2 is in opposite direction, therefore the magnetic field is also for the first one inward, that is into the paper, this is outward, it is out of the paper. So these two are in opposite direction, so the B net is B1 minus B2 because they are in opposite direction. Now, but I don't know the values of this I1 and I2, I have to calculate this I1 and I2. How do I calculate this I1 and I2? It's very simple. If you notice in the circular part, this upper part, out of the total circle circumference, it is having 3 by 4th of the length, whereas the lower part is having 1 by 4th of the length. So what we can say here is as resistance of any wire is rho L by A. For a given wire, rho is constant and looking like area is constant, area of cross section is constant, then resistance directly proportional to length. Then I can write R1 by R2 equal to L1 by L2. L1 is first part, 3L by 4. L2 is the second part, L by 4. When you add together, that becomes L. By 4, L and L will cancel. So the resistance is in the ratio of 3:1, and this yellow part and this other part behaves parallel to each other, as two parts are parallel. Potential is same, that is I1 R1 equal to I2 R2. That implies I1 by I2 equal to R2 by R1. R2 by R1 means 1:3. That means total current is divided as in the ratio of 1:3. What's the meaning of that? I1 is one part out of 1 plus 3, 4 parts. So I1 can be written like 1 by 4th of I. I2 can be written like 3 parts, 3 by 4th of I. How do you make sure that this division is correct? Just add this I by 4 and 3I by 4, you will get back your I. That's all. So that is correct. So in the place of I1, I shall write I by 4. In the place of I2, I shall write 3I by 4. Let us write both of them and see what happens to our answer is. That implies B net equal to, let us substitute that. B1 is this, mu naught by 4 pi I by R. In the place of I by 4, I by 4 R, and 3 pi by 2 inward. It can be shown with a kind of a cross, minus B2 means this, mu naught by 4 pi I2 by R. In the place of I2, I have to write 3I by 4 and then pi by 2. Look at this, mu naught by 4 pi is same, I is same, this is 3 pi by 8R, this is also 3 pi by 8R, both are same, so that is equal to 0. It means what, each magnetic field is cancelling the other, thus the net magnetic field is 0. That's how we get the answer. So to solve this answer, you need to know only one simple formula. Magnetic field in the arc shaped wire is mu naught by 4 pi I by R into theta. Not only that, you also need to know how do you decide the direction of the magnetic field. Whenever a conductor is carrying a current, to know the magnetic field, you have to curl your fingers along the direction of the curled conductor, then the thumb indicates the direction of magnetic field. Know that basics so that you get the answer. That's how we solve this problem. Thank you for watching.